B now. So it's an integration by substitution question. So we're going to solve this in the normal way for a substitution question. So we start with u equals tan x. So I'm going to differentiate my u, giving me du by dx. And this is a standard result from the formula book, that tan x differentiates to sec squared. So now what we're trying to do, remember, is to remove all of the references to x in our integral and replace them all with u's. So we're going to rearrange this to first of all eliminate our dx. So we're going to do that by just rearranging this. So du equals sec squared x times dx, and du over sec squared x equals dx. Okay, so we're now ready to substitute at least dx into our formula here. So we're going to do the integral of pi by 4 and 0. I've got sec to the 4x and the square root of tan x. Now you're tempted, I know, to write that as root u, but the best thing to do, and it won't make any difference in this question, is just to put in your dx first and see what cancels before we start trying to do too much with our u. And what we can see here is that we've got a sec to the 4 up there, and we've got a sec squared there. So the to the power of 4 and to the power of 2 are going to cancel, which is going to leave me with sec squared on the numerator, and then root tan, and at this point I'm going to write that as root u du. So my problem I've got is now I've got this not in terms of u. And so before I can complete this question and do my integration in terms of u, I need to rewrite sec squared in terms of u. Now, one of the trig identities that we need to remember for core 3 is that 1 plus tan squared x equals sec squared x. Okay, and that's perfect for this question. So we don't even need to rearrange it. So let's put 1 plus tan squared x in terms of there. Before I do that, just to save a line of workings here, I'm going to write tan squared in terms of u. And tan squared in terms of u there is going to be 1 plus u squared equals sec squared x. So let's now pop that into our equation, into our integral. So we've got pi by 4, these limits still in terms of x at this point, 1 plus u squared, and now let's write u to the root u as u to the half. Okay, now we're sort of ready to integrate. At some point we're going to change our limits as well, but I'm not going to do that just yet, just because we're going to get going on the integration. So we're still in terms of x, pi by 4 and 0. Now if I'm expanding this bracket, I've got a nice easy one, u to the half, and then I've got this second one where I'm multiplying these two together. Remember, with indices, if I'm multiplying, I'm adding the indices. So 2 plus a half is 5 over 2 du. So I'm now ready to integrate. I'm going to do my integration before I sub in my limits. So I'm going to have my final solution. So square brackets for this, add 1 to the power, divide by the new power. Now if I'm dividing by this fraction, that is exactly the same, let's just remove that, as multiplying by the 2 and dividing by the 3. Now if you need to see a little bit more on that, that's certainly worth exploring in your own time. So 5 over 2 then becomes 7 over 2, and again we're dividing by 7 over 2, dividing by that fraction, which allows me to write it as such. We're doing definite integration, so I don't need my plus c, and I've got my pi by 4 and my 0 in terms of x. So at this point, instead of substituting it back in, instead of substituting tan back in, I'm actually going to change my limits. Okay, so we know that u equals tan of x. So if x is pi by 4, then u is going to be tan of pi by 4. Okay, and if you use your calculator, you'll find that that comes to a nice round 1. Okay, and then when x is 0, u equals tan 0, and at that point it's 0. So instead we're going to have new limits to sub in, nicer limits I would say, 3 over 2 and 3 plus 7 over 2, so just copying down that question, and then I'm putting in 0 and 1. Okay, so that makes things quite nice because the 0, everything's going to go, so I just need to now worry about putting in the 1. Now this is not a show that question, so as soon as I've done all this and I've just written out this line to make sure that I don't lose any marks, I'm going to grab my calculator and very quickly just put this into the calculator as it is, and then we will see that we'll get the correct answer. So everything goes in brackets. This is all just sort of standard stuff now that we're expecting to do. So that's all over, calculator's not working, that's all over the 3. And adding to that, I've got another fraction, 2 lots again of 1. Just good practice to always put everything you're substituting in into brackets, because as soon as it's negative, it will start causing us problems if we don't do that. And we get the correct solution of 20 over 21. So close that bracket and then final answer 20 21s, and I've got my 8 marks.